We have been talking about work we're doing with Amsterdam for a longer time. So this is a research project, what we're now presenting from last 2 years until 2007. So we've been looking to Amsterdam. They have ambitions to recycle as much as possible. And we have started to with pavers. These are reusable in itself. They are property of the city themselves. They procure it. They control the waste. They think they can do a better job in procurement and administration, but also in hardware facilities. So this presentation is based on the work of a master students, alumni, Jery, together with me and Petar, on spatial logistical analysis of the flows for making space on a local scale for circular reuse. So we're speaking about circular hubs and the leakages of material that are inside, I would say, in supply chain terms. And these facilities are aimed to, and these analyses are aimed to possibly reduce the leakages of materials in the system. So Felix has been introducing this already. So we're looking at quite a portion of GHG emissions of pavers, that is road maintenance, and a continuous stream, which is for supply chain management approach. That's ideal, I would say. The manufacture bit is about 85–90% of GWP. So there's a sense to make use of the reusable materials in itself in a quasi-closed system within the city. Since most of the material is flowing, leaking out of the system, as we're already tracking down or suspiciously tracking down, it's mostly downcycled also. So since if you can't recycle it, then we are losing those GWPs. And Amsterdam is on track to miss its targets. So that's also a good driver always for the administrator level trying to get somewhere. So the city wants to get somewhere. So this is a snippet of work, action research, based on the work of the master of Jery. So what we've done here is look into locations for hubs. So storing, how many do we need based on the flows that are produced by the projects for the next coming years. So that's supply chain management logics. Based on the flows and the inefficiencies in the system, if we would put forward a network of hubs and transport flows in between, and to try to reduce on the total transport effort, which is in tonne-kilometers. So how much of the total materials, the total of projects in the coming years will produce on the roads, and how to optimize this. So to capture as much of the possible of the materials reusable, and to reduce as much as possible the total transport load. That's two aims of this snippet of work done by this particular candidate. So what are we looking to spatially? So it's a spatial analysis on the centralized situation which we have now. We have one hub, which you saw the robotized arm of for repacking existing materials, and on the municipality level. We're looking into decentralized modes of spatial planning, following the ambition of the city to enlarge the number of hubs in the city, and where to put them and why and how. So this is the aim of this study, and to put in maybe neighborhood storage sites as an intermediate location for additional optimization. So this is a hypothesis in this model to see whether that works in the favor of reducing total transport efforts. So what we have added to the circular construction hub, which are quasi-manufacturer situations on urban, on industrial zones. We're looking now at sub-local situation, like in streets, and temporary storage added to it, to reduce unneeded transport back and forth to circular hubs if it's not needed, and to create tactical buffers for contractors on projects directly. So that's a facility added to the network of hubs. So we've started with identification of potential hub locations, both for CCHs and TSSs, based on the project demography of the city. So where are the projects, what are the service areas around it, based on the total amount of projects and the distances they create. What are the locations, potential location based on demand proximity, and what do other kind of restrictions like limitation in residential areas, etc., prescribe where to put those hub locations. So we've found in this initial study 3 potential locations for CCHs, which are the stars, and the diagonals, which are the TSSs, based on this first spatial analysis. So to add the TSSs, so there's a two-tier configuration in the network approach. So we have sources, which are projects producing reusable products. It could either go to TSSs directly based on proximity, or to CCHs, or from TSSs to the CCHs. So this is the dominant concept of configuration behind this. So based on this first initial network, we found these transport efforts in tonne-kilometers, and you see that hub and spokes do make situation worse, and decentralized situations would improve the situation. But now we got operational inefficiencies added to this as a result of this analysis. So if we got the three CCHs, particularly the middle, was over demanded by the projects simultaneously supplying to those hubs, and also the second leg of transport was exceedingly high because of so the workload imbalance on this one of these three CCHs, particularly the middle one in the center, and the second leg transport, the distances that was too high as a result of the distances from those temporary storage sites to the three CCHs. So what was the need for network refinement was to expand the CCH network and to reevaluate the TCS placements. So we added two potential locations. So we got for CCH, so we got now 5 CCHs proposed by the experts involved in the research, and we got the eight TSSs changed by a analysis to how to put the TSSs to the CCHs in what situation, in what location. So taking again into account restrictions in land use, potentially due to environmental zoning, where these hubs would be possible or not, taking into account proximity of hundreds of projects simultaneously, and varying distances, and the impact of the total transport effort. So this would make a gigantic kind of like analysis. So here did the modeling kick in. So what was proposed is have 20 TSS locations in principle as a first round of analysis, put in the locations indicated by the previous initial network analysis, and to make the model run for optimization of total tonnage captures maximization. So we want as much as possible of the reusable materials captured by the hubs, for sure, for circular aims, but we want to have minimized distance for TSSs to CCHs, for disruptions, and particularly minimize the total tonne-kilometers transport effort pushing on the city infrastructure. So we want both. We want all. So the model was to try to model all. What was the result here? We found this elbow point of diminishing returns on 10 TSSs around the city, the diagonals, which were indicated out by the modeling. Like a mathematical optimum, we would say, to capture most of the material for the lowest transport effort and cost. So the TSSs would incur investments. 4 of the TSSs appeared unfeasible in undesired locations for environmental reasons and side effects to the environment. So 6 TSSs did suffice. So in the end, we ended up with, I think here, yeah. Okay, 6 TSSs. 2 of the TSSs appear to be on the location of CCHs, so 2 dropped out. So here is a proposed recommendation to combine 2 of the TSSs with CCHs. So we have a 5+6 or 5+4 configuration, what you like. So the impact of this refinement, we saw in the first run a reduction of tonne-kilometers in decentralized situation, and a increase of the tonne-kilometers transport effort in the hub and spoke configurations. And here we now saw a reduction of those transport efforts or transport burdens on the city from 26 by 33%. Now, decentralized seemed to be the most efficient answer to the question. You see the highest reduction in transport efforts on a city scale. in terms of tonne-kilometers, but we got these the expert insights from a few experts on city level, from a research perspective, from a governmental expert, and construction expert, bringing in all kind of like pluses and minuses for the TSS implementation. So the hub and spoke implementation preferred to the decentralized situation. So there's pretty undecided. So as a recommendation for the next phase of research, which will be starting soon, we got in go for the second phase of research till end of 2027 to implement this third tier 2D system, to have, for the sake of maximum reuse level of those pavers on the urban scale, in terms of logistical and spatial analysis, optimization. We need this permanent CCH infrastructure with high value processing capabilities, including robotized repacking and the standardized redistribution and quality check-in. Dual purpose locations where we can both do such or do perform such a part of such functionalities, including direct reuse among projects on a in a close-by situation where contractors can easily control those neighborhood staging areas themselves. So we got now an idea of a 3-tiered system based on this little snippet of research for the next phase, to now model in a 3-tiered model for the city in the next phase, which is the end of presentation. Thank you for your attention.